Happy Tuesday. Let's see, last time we looked at a volume, a solid of revolution, right? So a solid that is obtained by revolving a certain area about some axis, right? And we looked at the disk method for evaluating such a volume, right? We solved that for disk method. The function had to be of the same independent variable as the axis of revolution, right? So horizontal axis, you integrate with respect to x, vertical axis was with respect to y. Shell method is going to give us a way to keep it as a function of x if we're rotating it about a vertical axis. Right, so shell method is the opposite. If you're rotating about a vertical axis, it's with respect to x. A horizontal axis will be with respect to y. I believe we looked at this region last time, right? Rotating about, we did both the x and the y axis using disk method. Right, well, now we're going to do the y axis again, but we're going to use the shell method this time. So we're plotting what's just x cubed. Nice. What did I do? Minus 10 to 10? Or did I do minus 5 to 5? I don't remember. I think for this I had to go minus 20 to 20. Now we go 0 to 2. Sliding. Right, so there is the region R. Except this time, instead of doing disk method, I'm going to use shell method and see that we get the exact same answer. The line x equals 2. The formula for the shell method 2 pi times the integral from a to b of r times h dx. R is the same. R is measured as the distance from the axis of revolution to the region. H represents the height of the region. Okay, so we're integrating over 0 to 2. Radius. Depends on where you are in the region, though. It's just x, isn't it? Right, because x can go from 0 to 2. The radius goes from 0 to 2, so it's just x. For the most part, it's going to be x. Height. It's just a function. To whatever, to some point in the region. And then, of course, it's a sum, right? So you're summing up over several points. That's why it's just x. It's a simple integral. 2 pi over 5 times x to the 5th. The value from 0 to 2, that's clearly 2 to the 5th, which is 32. Times 2 is 64. We get a volume of 64 pi over 5, which should be exactly what we got when we did disk method. This method just required a bit more work to set up. Which means it does not matter which method you use. You can use either disk or shell. You'll get the same answer. The only time it's going to matter is if I specifically tell you to use a specific method. Like on a test, I might say use shell method to find this volume. Otherwise, you can use disk or shell. Easiest way to do it is disk method for horizontal axis of revolution, shell method for a vertical axis of revolution. That way you can keep it written as a function of x. Find the volume of the solid obtained by revolving the region in the first quadrant inside the circle x squared plus y squared equals r squared between y equals a and y equals r. A is going to be between 0 and r. And this region is being rotated about the y-axis. The solid happens to be called a polar cap. Vertical axis seems to suggest to use shell method. There is a problem if we do shell method. It's not really a problem. We're gonna have to do a difference. Right? We're gonna have to essentially do that and then minus that. Versus if we use disk method, it's a single integral. I'm going to go ahead and do disk method because it's the simpler method in this case. Vertical axis means we have to do this with respect to y. So what are the limits of integration going to be? Oh dear, that's not what I wanted. What was it? A to R. Then it was the radius squared. We need to represent this curve, which is x squared plus y squared equals r squared, as a function of y. What was it?
The square root of r squared minus x squared.
That's not a function of y.
Y equals the.
That's not a function of y. That's a function of x.
Oh, yeah, the other way around then.
Square root of r squared minus y squared, isn't it? And it's just positive because we're in quadrant 1. That's our radius then. Square root of r squared minus y squared. And I just need to evaluate this integral. R squared. Evaluate with respect to y is just r squared y, right? And then that will be evaluated from a to r. R minus a. The first term of the integral is going to be r squared times r minus a. Minus r cubed minus a cubed all over 3, right? Because it's y cubed over 3. Evaluate that, r to a. 2r cubed over 3 minus ar squared plus a cubed over 3 all times pi. Or if you prefer fewer fractions, back out to 1/3. And in fact, this is what is used as the formula for the volume of a polar cap.
That A value, that line at 2, say that's F plus 2, that's the number you just plug it.
Yep. As long as the radius is larger than 2, right? Because A can't be equal to the radius. Otherwise, you'd be, for instance, A would be right here, right? And then you no longer have a polar cap. But yes. Right, so just like when you have a cylinder, you have 2 variables you need, right? You need the radius and the height. Same thing here with the polar cap. You need 2 values, so radius and whatever they call that A. Plot the region in the first quadrant bounded by the 2 parabolas y equals 2 minus x squared and y equals x squared. We'll then find the volume of the solid obtained by rotating this region about the y-axis. Actually, first, going to need points of intersection. Right, so let's go ahead and solve. Get +1 and -1. So we're plotting 2 regions, or 2 curves rather. But it said we're in the first quadrant, right? I'm going to go 0 to 1. See how this looks. Spelling will be nice. saw another interesting color. Actually, paint sounds pretty cool too. I want to see how this is going to show up. What shows up on the screen isn't what I see. And so you don't see anything on there. On mine, I can actually see it. That's a bummer. That does not look like a spring green to me at all. That looks more like a yellowish. Of course, on the screen, it's completely different than my screen. Oh dear. Yeah, sure, why not? We'll go with Arkansas Razorbacks. One thing I hate about when they do plot labels. Why do they put it right there? Go ahead and just get rid of that and move you. Get rid of that and move you. Just to make it way more obvious. Remember, that's being rotated about the y-axis. So it's going to be shaped like a cliched flying saucer. UFO in the old, what is it, the 50s movies, where the aliens invade the Earth. This is typically the shape they go with. So that's fine, we're going to find. Disc or shell? Well, shell method is going to require me to write function of y, which I really don't feel like doing in this case. So this situation, I am going to use shell method. Oops, not two, one. Right? But we're going to have a difference. Right? The first volume we have to find is with that height. Then the second volume we're going to have to find is with that height and then take their difference. Distance from the axis of rotation is still just x. First height will be 2 minus x squared. Smaller height is x squared. It shouldn't be too difficult to see. This can be written as a single integral. So henceforth, I'm going to skip that intermediate step. And if you have two curves to deal with, I'm just going to jump right to the radius times the difference between the larger height and smaller height. Two x minus 2x cubed. And factor out that 2. You're left with 4 pi times the integral from 0 to 1 of x minus x cubed dx. Right. Integral of x dx from 0 to 1. Oh, that's unacceptable.
But I'm confused. The part up there where it says 2 minus x squared minus x squared, is that negative x squared?
It's just minus x squared, right? Because what we're doing is we're taking that larger height, which is 2 minus x squared, and subtracting from it the smaller height, which is x squared. To here? What's x squared minus x squared? X squared minus x squared. Or, I'm sorry, negative x squared, right, minus x squared. So what's negative 1 minus 1? So negative x squared minus x squared would be negative 2x squared, right? You also have to distribute that x through. Factor it out of 2.
So what was the point of doing both integrals like this instead of like just doing the one under x squared?
Because this is technically what we're doing. Right, we're finding a difference of volumes, but it can be written with properties of integration.
I didn't mean like that. I meant just instead of just kind of ignore the top curve and only look at like the bottom half of that solid.
What do you mean?
So then you can do stuff under x squared and then you have a cylinder. Then multiply by 2. Would that be fine?
Well, that's not really the region we're finding, is it?
It is.
Is it? You're saying under x squared and then multiply by 2.
On the cylinder of height 1 and then take away the like stuff under x squared and then multiply that by 2.
Cylinder height 1. So bring me up to here. Oh, I see what you're trying to do. That might work. I think it is. I think that region is symmetric about the line y equals 1.
Definitely.
Problem is, you'd have to actually show it if you want to do it on a test before using it. Because it's not obvious. Not as obvious as, say, x squared being symmetric about the y-axis. So it depends on the point, right? Because remember, integration is a sum of points. So radius, by definition, let's say we take that point as our sample point. It's that distance. It's the distance from the point to the axis of revolution, right? But since integration by definition is the summation of all these sample points, that's why it's just x, right? Because if this was just some arbitrary point, how would you find that distance? It's whatever x equals, right? This is the shell method.
Yeah, so that x is like always gonna be there.
As long as your axis of revolution is the y-axis, then yes, it will always be x. If it's not, then you have to adjust that radius just like we did with the disk method. And I do have an example of that.
X squared. I mean, I'm just happy to that.
Factored it out, right? Because there's an x common to both.
Yeah.
So it can be factored out. And then you're going to be left with this minus the x squared, right? And again, this was only to visualize why I can just go right to this step from now on. X times the difference of the heights. Yes.
Would like an okay way of showing it's symmetrical about y equals 1 be saying 2 minus x squared minus 1 equals 1 minus x squared?
I actually have to look into proving symmetry. Because it's not something I ever really used. I never used it because I didn't like geometry. Right, I know the y-axis because I know that means the function is even. I know the origin because I know that means the function is odd. And I know the x-axis. Essentially replace y with negative y and you get the same relation. That means symmetric about the x-axis. I don't know off the top of my head how you would do symmetric about a non-axis.
The distance from like the top function to 1 is the same as the distance from.
I mean, yeah, that makes sense to me. So I don't know why that wouldn't work.
But like that would be an acceptable proof.
Again, I have to look up how you would prove symmetry. I'm just not comfortable with symmetry aside from axes because I never liked geometry or graphs or anything along that line. So I always just ignored all symmetry and just did it the hard way.
You don't like graphs and you fought them?
I'm not a fan of graphs. I wasn't when I was younger. All right, so we have to evaluate this. X from 0 to 1 is just 1/2, isn't it? It's x squared over 2 from 0 to 1. And then minus x cubed integral of x cubed from 0 to 1. It's just a quarter. It's a half minus a quarter. Quarter. So volume's just pi. Welcome to math. You think that's bad? Take an advanced physics course and look away for a second. Actually, take an advanced physics course and pay attention to the entire class and see if you walk out understanding what the hell happened. I'm lucky if you understood a quarter of what happened. The half and the quarter is just evaluating the integral. So our volume is pi.
Way to tell when you did, you show.
Generally speaking, horizontal axis of revolution is disk method. Vertical axis of revolution is shell method. So we're going to rotate region bounded by y equals 4x squared, x equals 0, and y equals 16 about the line x equals -1, and calculate the resulting volume. So this is going to take some cleverness. You have to do contour plot because you're plotting a vertical line. Can't do that with regular plot. Go from -5 to 5. That works. I'm only working in the first quadrant for the region, right? So plot range, we're going to go 0 to, I have to go up to at least y equals 16. I actually want to go above that. 20. Oh, wait. I don't know why I'm doing plot range. It's for y. Y, 0 to 16, or 20. That's what I want. Contour style, I'm just going to make the axis red. Turn off the frame. Turn on the axes. I think that's all I need. I'm going to be safe and set the axes origin to actually be the origin.
If you really wanted to, would you be able to not use calculus and just use the previous problem's results?
How?
Well, you know what the volume of x squared on like from 0 to 1 is when you rotate it around the y-axis, and it seems pretty similar to.
Right, but we're not going about the y-axis.
Yeah, but it's similar enough that you probably.
You might be able to. But I mean, this is calculus, so we might as well just set up the shell method. I think that should be perfect. No, it's a vertical line. But that's it. That's what I want my axis to be. Now I'm going to go ahead and plot the region. I need to call this what, plot 3? We're between 4x squared and 16. Where does 4x squared intersect 16? 2, right? I'm just going to worry about plotting the region. Not right now. I already did that. I already got that stored. No, because our shaded region is only in quadrant 1. On blue because it sounds cool. Oops, that's not what I wanted. You are. And labels. Expressions. And so there is our region. So there we go. So I probably could have gotten away with cutting my plot domain down. Probably could have gone what, -3 to 3. Whatever, doesn't matter.
So the problem said it was the region bounded by 4x squared, y equals 16, and x equals 0.
Yep.
But there are 2 regions bounded by that. Like initially when I read it, I thought you were going to do the left region
Oh, why would I do that?
because I know that's just what I thought at first. And it would give a different result. So
It shouldn't.
well, I mean, it's a lot closer to the axis, so it's going to be smaller.
How would we differentiate between which side we would use? What language would we be looking for? Because I also thought that like that made the most sense and I couldn't find a different way to think about it.
I'm just so used to language or math. It's always implied to be quadrant 1 if it's between the x-axis or the y-axis and something.
Well, they said there was 1 region bounded by those curves, or they implied that, but there's 2.
Yeah, because it's implied if it's between x equals 0 and a curve, it is always implied to be quadrant 1 in mathematics. Right, the problem with the other region that you're thinking about is the axis of revolution goes through that region,
Well, yes. And you'd have to do it differently.
which makes it not preferable. You never want that.
I mean, you just split it into two, one cylinder and one thing.
Well, actually, you would just take. Would you do that?
You just split it into a cylinder and a normal thing.
If it divides the region perfectly in half, you just take half the region and rotate it about the axis, and you're done.
When you say perfectly in half, you mean?
I mean, symmetric about that axis of
Well, it's
revolution,
definitely not.
right? Isn't it?
Not about -1.
Yeah, it is.
You mean 4x squared? That
Oh, that's right. It's 4x squared, not x squared. Yeah, no, it wouldn't be.
no. You can kind of like visualize.
Yeah, no, it wouldn't be. I'm looking at my graph. No. Yeah, so it'd be really weird and awkward. I'm going to leave that for a more advanced course. For our purposes, the axis of revolution is never going to be in the region that you're rotating. Just wouldn't make sense. Remember correctly, I kept the test questions pretty simple, so that problem shouldn't arise.
You have a problem of choosing a quadrant or?
Yeah. Could have picked some really, really interesting test questions, but I didn't. I kept it fairly simple. And so it's being rotated about that line. The volume's 2 pi. Integral from 0 to 2. Radius. What is it? 3 minus x? I see what I know where you're getting the 3 from. You have the right idea, but you're executing it incorrectly. It's x plus 1. Right, because the only distance you want is from the axis of revolution to the y-axis. Right, because y-axis to a point in the region is x. So you just have that additional distance of 1 to handle. We have 2 curves. Means it's going to be times the difference of the heights. Larger height is what? It's the larger height? Larger height 16, isn't it? Now the question is, do I really want to do the algebra? Or do I just want to plug it in? I feel like doing algebra. I forgot my 2 pi out in front. There we go. 224 pi over 30. Okay. Y equals x cubed, y equals 0, y equals 8. That's what our region is bounded by. It's going to be rotated about the y-axis. We want the resulting volume. See if we can do this without plotting it. Shouldn't be too difficult. Y-axis says we should probably be using shell method. What do we think the limits of integration are going to be?
2.
How'd you get 0 to 2?
Well, you start at 0 and 2 cubed is 8.
I mean, 0 cubed is 0, 2 cubed is 8, so those are the points of intersection. What's our radius? Just x. Do we have 2 curves? So it's going to be a difference of heights. What's the larger height? What's the smaller height? There's our setup. Oops. All right, so 8x integral from 0 to 2. We're going to get 4x squared from 0 to 2, which is 16. Right, 4 times 4. Minus 2 to the 5th over 5. Yes, of course. So that's what? 80 minus 32 over 16. So 80 minus 32 would be, yeah, 58, no, 48, yeah. Times 2. Volume's 96 pi over 5. Oh, that one was easy.
How is it ensure that the graph or the region doesn't go below the x-axis?
Because x is starting at 0. Right, if you look at x cubed greater than 0, it lies above the x-axis. So that region won't go below it.
Okay.
Because remember, integral, what are you doing? It's area between the curve and the x-axis. So that's guaranteed to always be above the x-axis. Think I may need to plot this one. Region's going to be bounded by square root of x equals 0 and x equals 1. We're rotating about the line x equals 2.
Bound there.
Is region bounded by those,
Those are two vertical lines. And then a function.
right?
So both of them are infinite.
Square root of x.
Oh wait, you have it's not a function.
Right, square root of x looks like something like that.
Yes. So you're not drawing the bottom part?
So what's x equals 0?
A vertical line. Well, you didn't say you're
What's that region?
bounding at y equals 0.
That's always implied.
No.
It's always implied. The square root of x doesn't ever go below the x-axis. So again, it's one of those mathematical implications. I actually can visualize this region in my head. I'm just doing this for the sake of it's actually different than the two non-axis axis of revolutions we've done before. So what I want x to go from, I can just do 0 to 3. What do I want y to go from? 0 to, and why not 0 to 3? See how this looks. Axes. is on, set the origin. This is plot 4. One. Just to be safe, going to set the plot range to be the same thing, 0 to 3. Plot style. Black. Filling is with the axis. And now what color do we want? Why not a pink? You're just asking for trouble.
That's fine. Hey, calculus is fun. I'll make with the learning.
You're really asking for trouble. Oh, oops, wrong axis. There's 2. There we go. So there's what it's going to look like. I'm actually also fairly certain I can draw that arrow using Mathematica. I just don't know how off the top of my head, and I don't feel like researching it. Vertical axis tells us we should probably be using shell method. Limits of integration. They actually gave it to us. And this is why I plotted it. What's the radius going to be? What is it? What is it? It's 2 minus x. Oops, I probably should have used. That's the radius we're looking for. So that's going to be that minus the red. All right. So if you take the orange minus the red, you're going to be left with the blue. So that's why it's 2 minus x. Right. Again, do this enough, you're going to be able to visualize it. Oh, the axis of revolution is lying to the right of my region, therefore it's going to be 2 minus x. What is the height? We have a single curve, so it's just one height, root x. now my OneNote's doing some funky things. Two root x integral from 0 to 1. It's going to be 4/3 x to the 3/2. Evaluated from 0 to 1 is just 4/3. Mm-hmm. It did. Square root of x is 1/2. Right. Now I'm doing the 3/2 one. That'd be what? 2/5 x to the 5/2, right? Evaluated from 0 to 1 is just 2/5. Four-thirds minus 2/5. I'm going to have denominator 15. 20 minus 6, 14 times 2. Our volume is 28 pi over 15. Right. So that now gives you both scenarios where the axis of revolution lies to the left of the region when it's not actually the y-axis. Right now, one where it lies to the right of the region when it's not the y-axis. By the way, it's similar if you're looking at disk method and it's axis of revolution above or below. You have the same argument. But remember, it's still the radius of changing rate. You're squaring the radius. So we're looking for the blue, right? So isn't the blue the orange minus the red? That's why it's 2 minus x. What's the orange length? It's 2, right? And that red length is x. Right? Because x is the distance from the y-axis to some point on the x-axis, right?
This would definitely take longer, but would it also be fine to basically shift your graph over to like rotating around the y-axis and then do 2 separate integrals and avoid all the strange stuff? 2 separate integrals as in from -2 to 0 and from -1 to 0.
How'd you do -2 to 0 and -1 to 0?
Well, first you shift the whole graph over 2
right.
to the left,
Right.
and you find the area rotating around the y-axis from -2 to 0, and then you subtract the area rotating around the y-axis from -1 to 0 from that.
Right. Why wouldn't you just do -2 to -1? Right, because that's what the interval would switch to, right? It'd go from 0 to 1 if you shift it left 2 units to -2 to -1.
You probably could, but
Right, but you got to be careful because now your function changes. Your function will no longer be square root of x,
Yeah,
right? So you'd have to change your function as well.
but it would just be.
You could theoretically,
Yeah.
you could do that, yes. Shift it so that your axis of revolution is the y-axis. Yeah, you can do that. You have to be careful when you do that because sometimes it's going to give you, like especially if it's a horizontal, it'll sometimes give you a region that lies below the x-axis, which you're not supposed to have. The region is supposed to be positive for these methods,
Oh, that kind of thing.
right? So you have to then do some wonky adjustments there. You can still do it, but you have to adjust it. And you might also wind up with, again, some weird region divided. Now, you should never have it divided by the x-axis because then it would mean it was divided by the axis of revolution. But it could be that it now falls below the x-axis, which is a problem. Region bounded by root x and x squared rotated about the y-axis. Again, let's try and do this without relying on a plot. Let's pretend like we're back in the old days when I was in school and we weren't allowed to use calculators. First, what method are we going to want to use? You said,
Not shell.
really don't want to use shell?
I mean, no, the other one, Paul, that's why I didn't say his name.
Disk. I mean, you can use the disk method. It's fine. I'm going to use the shell method. Because it's about the y-axis. It's the vertical axis of revolution, so I might as well just use shell.
This, you have to make it as a function.
Yeah, if we were gonna do disk method, we'd have to do it with respect to y, not x. Which is why it's preferable to use shell method. But as the first problem today, and I think it was the fourth problem on Thursday, showed, it doesn't matter. Both methods are going to give you the exact same answer if you set it up right. So you can use whatever you want. Limits of integration. How'd you get 0 to 1? And where they intersect. Right, exactly, 0 and 1. Now, what is the radius? Do we have more than one curve? Which means we're going to have a difference of heights, right? Larger height. Smaller height. Over 0 to 1, root x is larger. From 0 to 1, it is, right? Because if you square a number less than 1, it gets smaller. If you take the square root of a number less than 1, it actually gets larger. Right? Square root of a quarter is a half. Versus a quarter squared is a 16th. So yeah, see, little weird there. But then obviously outside of 1, right? Once you go to the right of 1, now your x squared would be larger. You'd have to split that into 2 separate regions, which would be, again, kind of awkward, but doable. So if it's like 1 to 2, let's say, right, then it would be x squared minus root x. I'm actually going to write it this way this time.
Yeah, when I put the first one into my calculator, it told me something was wrong, but when I wrote it the second way, it was fine. I don't know why.
What do you mean?
Like when I wrote x parentheses square root x minus x squared in parentheses in my calculator, it said that something was wrong with that, it wouldn't work. But then when I put it in the second way, it was fine.
That means you probably typed it in incorrectly the first time. Either you're missing parentheses, or you put x squared under the radical, or something weird. Oh, you have to do x times the parentheses then. Right, that's what, if it means invalid, it said invalid implied multiplication, that means you have to explicitly write out x times the parentheses. Yeah, for some reason it does do that. Sometimes it likes implied, sometimes it doesn't. Be safe and just always do times. Integral of x root x from 0 to 1. 2/5. It'll be 2/5 x to the 5 halves from 0 to 1, which is just 2/5. Minus. Wait a minute. This is going to give me a negative. Which I can't have. Oh. No, I'm sorry. I was doing just x to the 4th, not a quarter x to the 4th. I'm back. Good catch. I was testing you. You passed. Congratulations. Or coffee. Maybe it's I need more whiskey in my coffee. Less coffee, more whiskey. Or scotch if I want a true Irish coffee. Speaking of that, St. Paddy's Day is coming up. And I'm Irish. So glad I have spring break that week. So it'd be what, minus a quarter, right? X to the 4th over 4. Right. Integral of x cubed.
Yeah.
Common's going to be 20, but I know that's immediately going to simplify. Just from that 2 pi, it's going to simplify. But I'll deal with that later. So 8 minus 5 is 3. The 3 pi over 10 would be our volume. So we're using shells to rotate the given region about the x-axis. Horizontal axis, shell method says it needs to be with respect to y. Close. Now, I'm going to assume that they don't mean cosine of y times e to the y, which is how it's written. I'm going to assume what they meant was e to the y times cosine of y. Because if it was cosine of y times e to the y, all y e to the y, you're taking the cosine of that, that would require numerical integration. Right? That does not have an analytic antiderivative. Versus e to the y times cosine of y does. So it'd be 2 pi times integral. We want limits of integration. What are the limits of integration going to be?
Is cosine e to the y times, or no,
E to the y cosine of y is how I'm going to
e
interpret
to the
that.
y.
Right, I'm going to interpret that what they meant there was cosine of y and all that times e to the y. Even though it's not actually what that says. How'd you get -1 to 1? Right, but it's not just cosine, is it?
So if you're using shell method, it needs to be like the original
Wait a
curve
minute.
needs to be a function of y, right?
Then your
So-
limits need to be with respect to y.
So how do you plan to do this? Like, I feel like the most reasonable thing would just be to swap all the x and y's everywhere in the problem. And then,
Why? We already have a function of y.
I thought we needed a function of x for,
X-axis, shell method is a function of y. Disk method would have to be a function of x. Remember, shell is the opposite of what you think. So if it's a horizontal, it's a function of y for shells, not x. Actually, now that I look at this, I think it is cosine of y e to the y. Otherwise, you wouldn't be able to get x equals 0. Oh, yes, you would. What am I talking about? Yes, you would. Set y to be pi over 2. Okay. I'm back. That'll be pi over 2. And then if x is pi, oh dear. That is going to be hideous. Okay. I like this problem already. Solve. E to the y times cosine of y equal to 0 for y. You do table form. And then solve e to the y times cosine of y equal to pi for y. I'm also going to do that in table form. Oh dear, it does not want to solve that one. Huh. So what if I did do it this way? Okay, I have no idea what they were thinking with this problem. This is right out of your textbook too. No idea. It's some kind of mathematical function. Now I'm curious, how do they want you to do this? Solution, so this is chapter 2, what section is it? 2.3. And it was what, 141? No, 139. Okay, there's no way that's right. That's got to be a typo. I wonder if they meant y equals 0 to y equals pi. And not x. Pi times integrate be what? Y times e to the y times cosine goes from 0 to pi. Yeah, that's what they meant.
That would be repetitive, but the problem itself, that one equals zero.
Well, apparently they did, because that's the answer they have. Which again doesn't make any sense because volume should be positive. So they just really screwed up on this problem. You're so eager for the quiz.
Positive, they get a 10 for the first time today.
I'm gonna hold you to that. So it's either 10 or nothing for you.
Run for all our confidence. We haven't done a fraction yet.